Hey everyone, so today I have my friend Alpha here again, and Alpha is in the top 5,000. Show this every time. Alpha is the top 5,000. He's done 1,400 plus questions. Has a crazy streak going. But let's just hop straight into the interview. I have him on um, Paul's manager. I have him on my coder pad right here. And yeah, let's get this first question in. So the first question, I'm gonna ask three questions here, and the first one is I'm just gonna get you to reverse a linked list. This has
Oh, nice, dude.
messed up a bunch of people, and this has like ruined a lot of people's six-figure dreams.
Yeah, I heard this used to be the Google question back in 2018, and then they stepped it up since.
There's been some inflation.
There's
Um,
been now you got sophomores solving hards, and it's just like now you got to design React in like 30 minutes or something.
yeah. All right. First question. Reverse this linked list.
All right. So I guess can we assume that we're given like a linked list? Like, can we just say we have like a list node class or something, right? Like the normal one. Like let's say we got this kind of thing where it has stuff. Yeah, I don't remember. Whatever. So val none or something 0 left. None right none. Kind of hard to type this stuff in.
Yeah.
But this is fine. So can we just assume basically like that it's gonna be something like this, like all the normal stuff?
Yeah, we could assume we have a list node with a left and right child and a value.
Actually, I don't know. I have a left child. Next equals right like this. Okay, there you go. I don't know why we have a
Oh yeah,
left and right
yeah,
child in a list node. Perfect.
yeah, exactly.
All right, like this, right?
Yeah.
Okay. Yeah, yeah. So assuming we have that, so just go to this first example. Yeah, so basically what you need here real quickly is just you need to store whatever nodes you're at next node somewhere, and then you need your current node to point to the one before, and then you need to move everything up. So what would happen here is like we'd have a previous node. Yeah, I don't know how to do it. I guess can I use a drawing? That would be a lot easier.
Sure.
Or do you want me to do it? Okay, okay.
Open up and drawing.
So let's say we have this some nodes essentially. Let me zoom out a lot. Okay. So I'm not even gonna put in values. I'm just gonna say we have like just some nodes like this, and then they're connected. Okay. So what we need is we need a previous node. So that will be like this color, let's say. We need a current node, and that's it. And so at every step, all we basically do is just make a next node, which is going to be the next of the current. So the current will start off being the head, and then we're going to make the current next point to the previous. So this arrow is going to turn around. Um, and then we just move everything up. So this will go away, this will move here, this will move here. Um, actually, is that right? Yeah, I think so. Okay, then we just basically keep repeating this. So we make another next node, we flip this to go here, and then we do the same thing. So we move both of
Wait,
these up.
what's orange and green and
Yeah,
red?
so let me write it. Green, previous node, whatever this pink current node, and the brown next node. Okay. So I can kind of demonstrate it
I
in
see,
this
I see,
next
I see,
part.
I see, I see, I see.
Yeah, so let's say these are here. I'll kind of go step by step, I guess. So first we make the next node equal to the next node of the current node, which is going to go over here. Then we make our current node point to the previous node. So I'll go over
You
here.
can draw two with seven.
I can draw what, sorry?
Or with seven, you can draw. That helps.
Oh, yeah, I see. Okay, yeah. Yeah, I guess that works. And then basically I just move them up. So I say current node equals the next node. Or actually it would be the other way. It would be previous node equals current node, and then current node equals over here. And then this gets removed. So we keep doing this, and then we have one more of those. So we'll set this equal here. I guess if we do 7, that will go this way.
Yeah.
and then we move them up again. So this will go up here, and this will go up here.
Okay.
And then we do that one more time. So yeah, I think this is the last one. Okay, and then we say this points to this, and then we move them up again. So this will go here, this will go here, and then when our current node is out of bounds, the previous will point to the head of the new linked list, so we just return the previous.
Okay.
So I think actually the drawing in the pseudocode is like more than what's the code. I think the code's like 4 lines.
Okay. Go ahead and
Okay.
implement.
All right, let me close this drawing. Okay, cool. So go def reverse list, and we'll just say it takes a head. All right, so we can just say previous equals none, and current equals the head. Say while the current is good. So you can do this all in like one line, but I'll just make it simpler. So we'll just say like next node equals cur next equals previous, um, previous equals cur equals cur equals next node. All right, and then yeah, I believe that's it, and then we just return previous here.
Okay.
And that should basically be
Can you
it.
dry run me on like a very small example with the code?
Sure. So yeah, so here, previous will be none, cur will be 1. Okay, so we're going to say next node is going to be 2. So then we're going to say uh, current, or yeah, current points to previous. So previous is none, so current is actually
Shabbat,
going to
real
point
one.
this
I
way.
appreciate you.
Then we're going to say previous equals cur, so previous will be 1, and then cur will be 2. And yeah, so then we do it again. So next node is cur next, which is 3. Um, cur point to previous, so it'll go this way. Yeah, and then previous equals cur, so that'll be 2. This will be 3. And then one last one. So next node here is null. Yeah. And then cur next is previous over here. And then previous equals cur, so 3. And then this is none. So now previous will be 3, and then we just return
I see.
3. And that'll be
Okay.
the reverse list.
Can you do this recursively?
Yeah. So I guess let's think about how we could do it recursively. Let's go back. Normally this is one of the ones that I would basically never do recursively
Yeah.
because it doesn't really seem optimal, I guess, but let's see if we
Why?
did.
Why wouldn't it be?
Because recursion takes up space, so it
Okay.
takes up space on the stack. So like if this list is 100 items, we're just gonna have like unnecessary stack space. Where with this solution, we just have like one extra variable.
I see.
So normally, if you could do iterative zero space, then you just wouldn't do recursive.
Yeah. Makes sense.
But yeah,
What's
okay,
the
but we
time
could
and
try it.
space complexity of your last solution?
Yeah, so this is time linear because we have to go through all the nodes, and space will be O1 because we just have that extra variable. But recursive would be O(n) space if we did recursive. Yeah, so I guess let me think about how I would do recursive. So I guess ideally we'd want to like pass in some shorter version of a list every time, I guess. So basically we would say like, okay, so we have this list.
Yeah.
So let's make so maybe we can like reverse this list and then get the end of that list and then have that list point to this node, and that would be the answer or something like that. Um, Thinking something like that. Let's see. Yeah, so we basically have to break it up in some way that makes it work like that. So yeah, I guess if we, I mean, we can return a bunch of things in Python. So I guess for a recursive call, we can return like the last node in the list and then the first node in the list or something like that. So what we can do is we can say like, okay, while we have a node, let's just take this node, let's reverse the other list, let's return the head and the tail of that list, and then let's just add this node to the tail. So it would look something like that. And then finally at the end we would return the head and tail like here, and then the answer would just be the tail value, or sorry, the head value here. So something like that. Does
Okay.
that kind of make sense?
Yeah. Go ahead and code it up.
All right. So we can say like if not head, then we have an empty list. So the tail and the head will be none. So we can return like none and none. And let's just say we're going to be returning here like head, comma, tail or something. Okay. And if we wanted this thing to return like only one value, we can just basically write a helper in here, call the helper, and then that would return like we can get the one value. But I'm just going to have this thing return both. Okay, so this is the case. Otherwise, we basically need to take our list, separate it from the next one, and then yeah, so we need to say like cur equals head, and then we need to say like the rest of the list is going to be, so I guess we can say like next node equals cur next. Yeah, and I'm trying to think, what if this is like the last node in the list? What would we return? Yeah, I guess if this node doesn't have like a next node, we can just return that node twice again. So we can say if not head.next, return. So the head will be the node, and then the tail will also be the node. Okay. So now we can basically say cur's head. This is next, and then we could say uh, like head or like new head or something. New tail equals reverse list of next node, but we also want to unknown. None is not iterable. Yeah, okay, so hold on. So next node is current next. So we have to actually break it as well. So we have to say current next equals none. Um, yeah, I'm not sure what this problem is. I don't know if you're like familiar with it. It says it's returning. I guess I'm
Where?
returning twofold unknown. Oh, it's probably because I'm just not returning anything here or something like that. Yeah. So head unknown. Okay. Anyway,
Oh,
so
don't
yeah, so
feel. Yeah,
basically,
don't have to run it. Maybe I'll just run it in LeetCode.
okay,
Worst
yeah,
case.
whatever. So then what we have to do is we have to say new tail dot next equals cur, and we just return the new head here. So it'd be something like this, and then this would need to be a helper function in the actual reverse list function because, or actually, let me think. We need to actually no we need to return both. Yeah, so we need to return both. So it'd be like return new head, and then I guess new tail would be cur, something like that. And then you would need to call this in the actual like, so this is going to return the new head and the new tail, so you're just gonna want like the first value there. So I actually don't think it'll run just like this in LeetCode.
Okay. How would it
But
run?
yeah.
How would you make it run?
Okay, so if we want it to run in the actual LeetCode, we can make
I
a
want to
helper
test your
function.
code.
Okay, yeah. So we can have like a helper, def helper, it'll take a head, then we could do all this in the helper. Okay. And so we will say, so we could say like new head, new tail equals reverse list head, and then we return the new head. Now I do want to see why this is failing. Do you have it like highlighted or something, or what's going on here?
See. I'm gonna run your code. Okay. Nice. Yeah, your code works on in GitHub. So we're gonna move to, or sorry, in LeetCode. So
Okay.
we're gonna move on to the
I think
next
it actually
question.
needs to be like this. So, but yeah. Okay. Okay. Yeah,
Okay.
let's move on.
We're gonna move on to question 2. Good job on that. Doing it iteratively and recursively. Recursively is actually not that trivial compared to
Yeah, I
the.
will say for a lot of these, one solution is easier and better. And so, like, if one, like, for example, for binary search, I know you can do binary search recursively. but it seems really silly for me to do that. So when I read it, like it's actually hard for me to understand because I would never do it like that.
Hmm.
So this is the same kind of thing, I guess.
That makes sense. Okay.
Okay.
Moving on to the second question.
Hmm.
So, pretty much, we're going to be given an array of positive integers where each integer describes the weight of that index, right?
Okay. Yeah.
Then we need to implement a method that randomly picks an element in that array. And we want to pick that element based, like the probability has to be based on the weight inside of that array essentially. So I
I
mean, it's
see.
better example. Pretend I do 1 5 1 4 5 here, right? So
Hmm.
since the total weight of the array is like 10,
Hmm.
right? The first element should be picked 1 out of 10 times if we ran this 10 times on
I
average.
see. Yeah.
Like probability 1 to 10 that we choose this zero, 4 out of 10, and then 5 out of 10 for the second or third or second index, third element. Um,
Yeah, I think I get it. Yeah. So yeah. So in this case, yeah, 1 out of 10, 4 out of 10, 5 out of 10. Yeah. Gotcha.
yeah. So
So when we
that's what
so
we want to
so
do.
this pick index is gives an okay. So what is it? Can you write like what the function signature here looks like? Like
Pardon?
we're yeah, for this pick index, like we're is this a class or something? I guess we have like a class and the pick
What are you
index.
thinking? What are you thinking? I mean, we should probably initialize. We probably have like some constructor,
Right,
or
I'm thinking
yeah,
class.
yeah.
Yeah.
You lead it. Like, what do you think? It's how like what makes sense
Hmm.
here?
So we're gonna have a class. It'll have some constructor. Um, we save the array, and then we'll have a pick index method that will take in nothing and just return. So does it return an index or the number?
Index, index,
Index. Okay,
index.
so return random index based on weight. So I think this is what I'm thinking. We want something like this. Um, okay. And so, yes, I think the way to do this is going to be, um, so we can basically just say like let's say here, um, yeah. So we can generate a random number. I'm trying to think. Like yeah, okay. So we want to generate a random number, with like random randint or whatever. I can look that up. In the range of, I guess like what would this be? So this is so like in this case, we can basically say like for this array, if we pick a one, we'll get this. If we pick two, three, four, five, we'll get this. And then if we get the top five, we'll get this. So I think we want in the range of one to sum of array. And then we can basically figure out like what does that number correspond to. Um, and so the brute force, I guess, would be like let's say we pick seven. We can just keep going up this array and add up numbers until we get the range we want. So if we get seven, we'll say like, okay, so our sum here is one, so we didn't get the seven yet. Now our sum is five, we still didn't get the seven. Now our sum is 10, so we got the seven while adding this number. So we return this. And if we get like two, for example, it wouldn't be this, but then when we add this, we'll get five. So does that kind of make sense? Like we just go down our array, add up numbers until we get to the one we got, and then that's the index we return.
Okay. What's the time and space complexity of that solution?
Right, so that is going to be, so this pick index specifically. The constructor will save the array, so that's O in space, but the pick index, that would be linear time, and space would be O1. But I think we can do better. Yeah, and the way we can do better is so here we basically have to like manually scan,
Yeah.
but instead we can do like a sums, so like a prefix sums. So we can say like, instead of storing the array this way, we'll store prefix sums. And it'll look like this. So just basic prefix sums where it's just like the sum of the array up until that point. And now, in this format, we can binary search for our solution. So we're going to look for the first number that is greater than or equal to our random number. And now this is just a binary search
Mm-hmm.
because this is going to be increased in order, all that. So like here, if we pick 7, we'll just look for the first number that's bigger. It'll be 10. We just return that index. If we pick 4, it's going to be this guy, and so on. And assuming we only pick from 1 to the sum, like the last number will be the sum, the first number will be whatever, we're always going to like hit something here. So I think that's going to be the way to go, is we do prefix sums, and then we just binary search through our prefix sums and just generate a random number from 1 through the total. Does that make sense?
Yep. Makes sense. Go ahead and code that up.
All right. So we'll have a. Honestly, don't remember how to make the class. I feel like it's like. Do you do class in Python? I don't
Yeah.
remember. Okay, so I guess class. Let's see. What would we call this? Like random number or something? I think it's like this, right?
Yeah.
All right. So we're gonna take in some array, and we're gonna say. So what we want to do is for this array, we want to generate prefix sums, and we want to get a total. Can we assume the array will have numbers, and they'll all be like positive? I guess it wouldn't really make much sense otherwise.
Yep.
Okay. So we can just say like this, and then for self prefix sums 0. All right, and then we'll just go for. I mean, there's a bunch of ways to write this, but it's fine. Okay, so for this, self prefix sums I equals total, and then we just do that. All right, so now we have our prefix sums, and then we're gonna do the random number. So index self. Yeah, I don't remember the syntax for the random number, so we'll just say like r equals ran. I think it's like a random.randint or
You could like,
something.
yeah, import random, rand int, and it's like
Yeah, it's like
inclusive
random
like 0, and that will give you like 0.
randint, right?
Yeah.
So we want to, let's see, in the range including both endpoints. Okay, so we want to go like this to self prefix sums. This is going to be our last one. So I think this is right now. Okay, so we have this random number. Now we are going to, yeah, basically just run a binary search. So 0 length prefix sums. All right. And we're gonna store. So yeah, I guess this is like personal preference for how you do binary search. Let's say, so we want. I guess what do we want here? We want the smallest number that's bigger than. I mean, we're always gonna get that, but I'm trying to think like what would store. Honestly, I'm pretty sure we can just do this, and it would still work. Okay. So we can say this. Okay, pivot value, and then yeah, you can do that. This guy instead, but you can just do this in Python because you don't get overflow. This is what I'm used to doing. It's another language you can worry about it. So we can basically say like if prefix sums of the pivot is greater than or equal to our random number, then this is a possible result. So we'll store that index. And then we want to check numbers that are smaller. So we'll go this. Otherwise, we can go the other way. Where, yeah, honestly, I think you can store this as like, I don't think it matters. Yeah, I guess we want the small, so we'll just go like, okay. So, yeah, so if we want the other way, if this is too small, then we'll go this way. And we just return, the result should be the index. Okay, I feel like that's it. We
Okay.
can like do a dry run if
Yeah.
you
Give me
want.
a dry run on 1.5 and like
That guy?
yeah, this guy right here.
All right. So, so our prefix sums here will be, so we're essentially just keep adding the number, and then yeah, so this will just be like 1, 5, 10. So let's say we go to pick index and we pick like 6. So pick index and we get the random number 6. So here left and right will be 0 and 2. So the first pivot value we're going to pick is 1. And then, oh yeah, and the result will be 2. So the first pivot value we're going to pick is 1. And we're going to check what's the value compared to the right. So here it is smaller. So because it is smaller, we're going to move our left to pivot plus 1. So left will be 2. And then we're going to get another pivot value. So now it's 2 and 2, so pivot will be 2. And we're going to get this 10. And now this 10 is bigger, so we're going to hit this case. And we're going to set the result equal to that, so 2. And then we're going to say right is pivot minus 1, so pivot will be 1. And now this will no longer be true, so we're going to break out of here. So we're going to return 2 because that's going to be this value here. Yeah, that's correct.
Okay.
Okay.
Let me put this in LeetCode.
Okay.
I think what you said makes sense.
Mm-hmm.
Yeah, damn, you destroyed this interview. 26 minutes, 2 questions already. I gave you an easy one for the last one, so I need to give you one more question.
Yeah, that's fine. Yeah, just don't give me some 80 lines of code one.
Let's see. Chat, what are you thinking? Oh, I got it.
And it is kind of crazy also, I will point out, if you're used to doing something in one way, and then people ask you to do something even basic in like another way, it takes so long. Like, it's crazy. Because you're like, I use this template for like all my problems. Now I'm going to try this thing. And it definitely is a lot slower.
Yeah. Um, people are trying to make me ramp it up, but you already did. It's already late for you. I'm gonna ask you this question.
All right. Okay. So, given an array of strings, names of size n, create n folders such that at the ith minute you'll create a folder. So names I. Since two files cannot, if you enter a folder that was previously used, system will have a suffix. Oh, I see. Oh, okay. Create folders in your file system such that the ith minute. Okay. So they can't have the same name. The system will have suffix. Okay. Return an array of strings length n where answers I is the actual name system will assign. Alright, so I guess let's look at this example. So PS, okay, and they just go like in order. Yeah, so you'll make one every minute or something. Okay. So PS is not taken, FIFA is not taken, GTA is not taken, the other one's not taken, so you just write them as is. Okay. I see, so this one is taken. Um, okay. And then One Piece, something. One Piece, One Piece 1, One Piece 2, One Piece 3. So this should be One Piece 4. Okay. Yes, I feel like this is like the tricky, like this is basically the whole problem of like how to deal with this case with the same folder names. Like if
Yep.
it's not, it's all super easy. Like if they were all different names, you're just done.
Okay.
Um, so the tricky thing here is like how do I store
Keep
these?
explaining. I'm grabbing my food quick. Just keep explaining it like you would explain it in like a
Okay,
video or something.
yeah, I'd have to think about it, but yeah. So the tricky thing is here, I guess, like how do you store these in some data structure where you can quickly check like what's the next available one? Hmm. One Piece. Wonder if, yeah, this is the only, and yeah, I guess like if there's One Piece 2 or something, then you would do, yeah, so no matter what, you can't escape the problem of turful, so some previously used. Yeah, you can never avoid this issue either, which is kind of annoying. Like if you get, um, let's see, One Piece 2, One Piece 3, One Piece 3, One Piece 2. Yeah, so if we get like One Piece 1, then we have to get like One Piece 1 or something, I think. Is that right? Let's see. Previously used. Yeah, no, it is. Yeah, okay. Returns unique. GTA 1, GTA. Okay, now, okay, I see. So where to get it, maybe? So for One Piece, what would it be? For One Piece, we'd store like the first available index is 1, I guess. And we already have One Piece in here.
This guy's
And so we
interviewing
basically have to
himself
break
now.
off the end and then see what we have. So this is like One Piece with a 1. Maybe not, though. Yeah. Okay, you
Wait,
back?
yeah, I'm back. Which part were you thinking?
Yeah, I was thinking this kind of does get confusing because I was gonna say like maybe we can change this to, like One Piece 0 or something and change it back.
Mm-hmm.
But if we have this case, then this would need to turn into like One Piece 1 or something, right?
Exactly.
Which is like the tricky part. So we can't just like manually put in a 0 and then like have a hacky fix to
This
that.
would be like this. One. Good job catching that case.
Right. And that's what makes it kind of difficult. So if this was One Piece 1, this would be like One Piece 1. Then this would stay One Piece 3, and then this would actually be One Piece 2. Okay. So, hmm. So I do think we do need to store some way, like some kind of hash map where we have where we have like the string name and then like the smallest possible number. And if we haven't seen it, we can just do nothing. But if we have seen it, then we can like add on stuff to it. Something like that. So maybe let's kind of walk through with this. Like this is kind of like the tricky one. So let's say we just have a hash map. And so let's say like One Piece we've never seen before. So One Piece we can just write out as is and maybe we'll store it in here. So yeah, like One Piece we haven't seen before. So we can store this as like One Piece. And now the first available number for it will be like a 1. So if we see it again, we're going to put in a 1. Now we get to this One Piece 1, and we haven't seen it either. But we have to somehow mark that for One Piece, it's not available. Because like you can't do that. So that's the tricky part. So maybe for like a number, if it's available, um, yeah, if it's available, then we have to somehow figure out how to mark that like it's not available for the one before. And I guess if it's available, then yeah, okay. So I'm thinking if it's available, then the one before has to be that number. Because like let's say for this One Piece, if the smallest available one is like 5 and we're on here, then we definitely can't do it. So I think if it's available, we can just mark the one before to do this. And then so we'll write One Piece 1. Now we get to One Piece 1, and then we check is that available? And the way we're going to do that is we're going to remove the um the number, or actually, are we going to remove the number, or we're just going to check the number? So we're going to check. No, I think what we're going to do is we're going to check for One Piece is 1 available, and for this it says the smallest available is 2. So then we'd say this wouldn't be available, and because it's not available, we're going to add a 1. So we're going to say actually One Piece 1. Now the smallest number available is 1 here. Actually, so when we're adding a number, is the smallest number we're adding 1 or 0?
One
Let
or
me read it
zero?
again. Yeah, we're adding 1, right?
Yeah, we're adding
Where
one
k
to
is the
it.
smallest positive. Okay.
Yep, yep.
Okay, so yeah, so we're gonna add a 1. And then we're gonna say that the smallest positive available here is 2. Yeah. And then One Piece 3. So we're gonna check. Okay, we have a 3. What's the smallest available? Oh. Yeah, it also might be tricky if you have like One Piece 3, but then you have but then you have like more one pieces or something. So if you had this case, if you had like one piece 3, how do we even do that? Not
Yeah.
sure. And then we had like more one piece here, like one piece or something.
Mm-hmm.
I wonder if we could just like do some sort, and then that would kind of take care of all our problems. No, we can't because we have to maintain the original order, so that wouldn't
Exactly.
work.
Exactly.
Yeah. Yeah, I feel like it's kind of tricky. Yeah, so for like one piece 3, we could say that this is actually not available. Okay, maybe when we try to add the, okay, okay, yeah, maybe we can kind of go the other way. Maybe we can try to add the number we're at, like whatever number we're at, and then just check like have we used this already. Maybe that's the better way to go about it. So let me see if I can figure that out. So if we go back here, we can basically say like, okay, well, we have one piece. So is just one piece straight up available? Yes. Okay, so we'll write it in. And then we're going to say, okay, so for one piece, the next available number is 1. Then for one piece 1, we're going to say, okay, is one piece, yeah, is one piece 1 available? Like, have we added that in? And what we can do is we can just have a set of everything we've already used. So this will be like in a set. So we could say like one piece 1, is this available? Yes. So then for one piece 1, the next number we have to add in is 1. And then for the next one piece 1, we're going to say, is this available? And it's already like in our set, so it's not. So we can basically just probably just increase this to the next one and then check is that available, and we keep doing that. And then that won't be like that bad runtime because worst case, yeah, I think that runtime will be fine. So I think something like that seems like the way to go. So we're gonna have a set of all the things we've already used, and then we're also gonna have a hash map of like all our numbers and what's the next available number, and we're just gonna manually like increase the number and keep checking have we used that, have we used that. I think that's the way to do it. Does that make sense?
Makes sense. Go ahead and implement. We have about 7 minutes left.
Okay. Okay, so what's this thing called? Let's see. Okay, we'll call it like folders or something. All right. Okay, so we're gonna have like a visited, and we're gonna have a um yeah, basically a like what's another one? Counts or something, whatever. Okay. Import default dict. Okay. Something like this. Okay, so we're gonna say we're gonna have a result array as well. So for string in R. Okay, so first we're gonna check if it's not in counts, we can just add it in right away. Or if it's not in visited, we can add it in right away as is. So if string not in visited, then we're gonna add it. And we're gonna say the next available number, string equals 1. And we're gonna add it to the result. And we'll just like continue or something here. Okay. So if we have seen it already, then we have to figure out like what's the next available thing. And to check that, we're basically gonna take what's yeah, and I guess I didn't ask, but I can assume like these strings are pretty short, so even though we're like making new strings, it's not gonna be that bad.
Sure.
Okay, so yeah, so I guess here we'll say like while, or we basically have to take the count of the, we have to take the count, so we have to take counts equals counts of the string, and we have to basically keep trying to see if this is available. So while string plus, I guess we have to make a string here, right? So while, yeah, so I guess we'll make the string. So we'll say like new string equals string plus whatever plus what was the other thing? The count. Yeah, you can definitely do this cleaner, but okay. So while new string in visited um count plus equals 1, and then we like rebuild the string. And when we finally figure out, like, okay, this is the one we're using, this is the one we're going to put into the result. So we're going to say visited, add new string. And then we're also going to say that this is the count we used. So we probably need like the next one. So we'll say like counts string equals, this is the one we use. So it'll be like count plus one or something. Yeah, I feel like that's it. Could be wrong, but I feel like, yeah, this looks pretty good. Maybe we can go through your example. Definitely not as confident this one. Maybe it's a metric case. Maybe it's too slow. But yeah, I feel like this is okay.
Try running it.
Definitely a
Or
lot
sorry.
harder when you can't just run it in LeetCode. So.
Try do a dry run.
Okay. So let's go through this example 3. Okay, so we're going to hit one piece. So one piece is not in visited. So we're going to say visited is here. Counts is an empty hash map. Result equals an array. Okay, so yeah, so one piece is not in here, so we can just add it directly. Yeah. And then the count here will be 1. And we'll add it to visited. So one piece. Okay, now we're going to get to one piece 1, and we're going to check is one piece 1 in visited? No. So we're going to add one piece 1 to visited. We're going to say the counts of one piece 1 is 1. And yeah, and then we're going to add one piece 1. Okay. Then we're going to say we have one piece 1 again. So this isn't visited, so we're going to go through the next thing. So we're going to say, okay, well, one piece 1 is in here. So the next string we can make is one piece 1 like this, one piece 1 1. We're going to check, is it in visited? It's not. So this is the one we're going to put in. We're going to add it to visited. And we're going to say this now has a count of 1. Okay, now we get to one piece 3. So is one piece 3 visited? No, so we can just add one piece 3 directly. 3. Okay, and then this will go in here and in here. All right, and then one piece 2 is also not in here, so we're going to add one piece 2 at the end. So one piece 2 will go here. This will have a count of 1. And then we'll add it to visited. Yeah, so something like this. Like I said, this might be too slow. I think it will always work, but my concern is it might be too slow and I might have missed an edge case.
Okay.
Yeah.
So okay, walk me through line by line again. You don't have to dry run it, but I just want to verify.
Okay, yeah. So, of the code,
Yeah.
you mean?
Yeah.
Yeah, okay. So we're gonna have a visited set, which is just like everything we have in a result. And then we're gonna have counts of like counts will tell us like the next available number we can use. And then we're gonna have a result. So for every string, if it's not in visited, we can put it in as is because like if it's not in, yeah, if we haven't put it in already, we can just put it in as is. And we're gonna say the count of this string is 1. Honestly, we can probably use visited. Yeah, I feel like we can get like to clean this up, we can probably get rid of visited, but let's just keep it for now. Because counts and visited are basically doing the same thing. So we're gonna say, yeah, the count of the string is 1. We're gonna add it to our result as is, and then we're done. So the other case is if the string is in there, then we're going to say, okay, what's the next number we need to add? And we're going to start with 1.
So is this an else statement then? Like,
No, because we continue. So it kind of is an else, but I just put a continue. So it'll do this and then continue if it's this case.
okay.
Like it's the same as, it would be the same as writing else and then like
Yeah.
all of this would be an else
Oh, I
block.
see. I see.
Yeah, so if it's already visited, then we're going to check like what's the next available thing. We're going to build up the new string. And we're going to check, is it in visited already? Like, can we put this in? And if we can't, then we're going to try the next one. And so we basically keep increasing the count from what we had until we get a new one that's viable.
Yeah.
Yeah. And then we're going to store like that. So whatever we put in, then we'll put in like the next count.
I see. I
Definitely,
see.
like I said, definitely easy to make mistakes on without running in LeetCode. So I wouldn't be surprised if it made some. But yeah.
Yeah. There's a small issue. I think like for us this case right here, um,
Oh, which
it
one?
breaks on this case right here. I ran a leak code for you.
Oh, okay, okay.
You're
So,
outputting this. This is your output, and the expected is like
oh,
you're missing a value.
I'm only
Yeah,
outputting
exactly,
3.
exactly.
Oh, yeah, okay. So, yeah, you're right. So I need to actually add this to the result, right? So
Yeah,
it'll be like, yeah, I did miss that,
I see, I see.
if that's the case. So that's, yeah, so try that. Yeah, I was thinking I'd miss something bigger. Hopefully it's just that.
It's running. It's running.
Might get TLE or something.
Honestly, this was my solution too. I don't know. I couldn't think of anything faster.
Hmm.
It gave a wrong answer on like on this one. I'll show you. This is the input.
Hmm.
This is your output, and this is the
I see.
expected. Like you just jumped to 3 essentially.
Okay, so let's figure this out then, I guess. Okay, so output. Okay, so this makes sense. This makes sense. That makes sense. Kaido 1-1. So yeah, that makes sense. So it jumped here to 3.
Oh, I see. I see. I see.
Okay, I see. So it wants to do Kaido 2-1, but it did Kaido 2-3. Interesting. So what would be
Yeah.
in this case? So in this case, it would just look like is yeah, I guess let's walk through the code. So these would all be in here, and then Kaido I think would be on yeah. Um, let's see. Yeah, it definitely is hard without like logging stuff at all.
Mm-hmm.
So and for what it's worth, I think for like these types of problems, if you're not allowed to run anything, and you do have like some small cases, I think it's like expected because it's kind of hard to get it like perfect off the bat. But yeah, let's take a look. Okay, so I guess we can dry run through this one. So Kaido wouldn't be in here, so let's have the same thing. So we'll have the visited, the counts, and the result. Okay. So in the beginning, Kaido wouldn't be in here, so we're just gonna put that. Counts will be Kaido with a 1. Result will be that. Okay, Kaido 1, not in visited, so we're gonna put that in just as is. This will be 1. This will be this. Okay. Um, so then the regular Kaido. So we're gonna say, is 1 available? No, it's not. So then we're gonna try 2. Is 2 available? And it should be. So we're going to put in 2. And now we should, let's see, count string append. Let's see how I did this. Count plus 1. Yeah, okay. So count, yeah. So then I think in here, this should store 2 now. Actually, should it store 2 or should it store 3? No, yeah, it should store 3. Oh, actually, no, this is wrong. So this will be 2. This will be 3. Yeah, because it'll, okay, so it'll be like this. Then it'll put this in here.
Mm-hmm.
And it will be visited. Okay, so now we go to Kaido 1. So Kaido 1, the first available number, it says it's 2. So what we're going to put in is Kaido 1, 2. And, or actually, no. Kaido 1, actually, I think this stays like this. Yeah, this stays like this because we never added another one. Okay, so Kaido 1 would have this, and we check is this available? Kaido 1, 1, and it is. So now this will be 2. Yeah. And we're going to put in Kaido 1, 1.
Connor, I don't watch
and we're
him
gonna
too
store
much,
that in
but for
visited.
like most of the time, I just see the candidates like getting
And then
roasted kind of
this
thing.
will
I
be
never seen
one.
the
Okay, so now we're
actual
gonna check
advice questions.
Kaido 2-3 or Kaido 2-1 actually. Or sorry, Kaido 1-1. Okay, so Kaido 1-1. Um, actually, sorry, no, we're gonna check this one. We're gonna check Kaido 2. So Kaido 2 is in here. Yeah, it is. So, or this, actually, this should be like this: Kaido 1, Kaido 2. This was Kaido 2, right? Okay, so this was Kaido 2. Um, and then, and then, yeah, like, well, actually, once we stored this, then what would happen? Let's see. Count string, count plus one, res append, visited. Count string, count plus one. Oh, okay, I think I see the problem. I think if it's a new string, we don't want to do counts plus one. Yeah, I think the problem is right here. So if it's a new string, we don't want to do counts plus one. We want to make sure, like if it's completely new, we just want to do one here. And I think that's the problem. So for this should actually be one. And yeah, okay, so that's the problem. So how do I fix this? So what I can check is actually, so this should be basically um, counts new string, I think should just be one in that case. And that's what I need to fix. So this is, or it could actually be, let me think. So if I have this, um, one, one, yeah, I mean, I want to say it's just like this.
Sorry, I meant to. I think overall the solution makes sense.
Yeah, and then I
Yeah,
think I need one more thing here. So I think I need to say count plus equals one, and I need to add it. I need to do count string uh, plus equals one. Yeah, something like that. I think I'm missing like literally like one line of code, and then it'll fix it. Yeah, I think this might work. I'm not
I
sure.
see. Okay, let's try.
Okay.
Yeah, this one's a
And then yeah,
bit tricky.
if it doesn't work, then I was just gonna give up. Yeah.
Yeah, yeah.
Yeah, I
If
mean,
it
if
doesn't
I could
work,
like debug in console log and stuff, then I'd find it, but it's kind of
yeah,
hard to just do it all off of like the code, I guess.
yeah. Let's see. Yeah, how do you think you did on this time around?
Yeah, so definitely the recursive one I don't know super well, but I would be kind of
Nice. Okay, your
shocked if I
solution
could answer it.
worked. Yeah.
Okay, yeah, yeah, I would say like without actually logging, it's super hard to figure out what's going on.
Mm-hmm.
So yeah, I'd say the recursive one I could have done a little bit better, but not too bad. I do know I'd be slow with it, but I also feel like it's more complicated.
Yeah.
But overall, fine, I think. This one I was pretty happy with. I can get it pretty quickly. And then yeah, this third one, honestly, I feel like I don't know, like maybe I'm just bad at some problems or something. Yeah, I feel like it wasn't super obvious, and the thing that tripped me up was like I wasn't super sure if it would be too slow because it seems kind of like a brute force where you're literally just trying numbers.
Yeah.
But then thinking about it, like it's actually not that bad because worst case scenario, you're not going through that many numbers. So definitely could be improved on this one, but I feel like
Yeah.
if I had to like rate per problem, I mean the first one I guess would probably never get asked, so don't count. So I think for this one, I'd probably get like a strong higher for the pick index,
Yeah.
and then for the second one, like I said, I feel like if you don't get to run the code, you're not expected to get it like all perfect with no mistakes. So I'd probably say like lean higher for that one or something like that.
Yeah. No, I think
Would be
yeah,
my
I think
guess.
you did good. My favorite part is that you could interview yourself. So I could step away and you're literally starting to read.
Yeah.
So people in the chat were saying they could, what did this guy say? Something funny.
Yeah, I think that's usually feedback I got from interviewing because I make so many videos and talk a lot. People are like, "Oh yeah, your communications are really good. You
Yeah.
you never really like not talk."
Yeah,
So
someone's like Alpha is both the interviewer and interviewee. Because as soon as I
yeah,
did, I was like, Alpha, just run it yourself. I need to eat. And you just asking yourself questions and then answering it, and then because that's how you do when you're doing a YouTube video, right? You're asking yourself some questions, then you answer it.
yeah, pretty much. Yeah, it's like a mock interview with myself.
Yeah, and you always like, yeah, you mock interview yourself like crazy, even with the other stuff.
Yeah.
Can
No, I mean
you?
definitely the system design stuff. I gotta get a lot more
Yeah.
feedback because I don't know it as well. But this stuff, yeah.
Can you ask him if it would be great practice to make those videos of blind 75? I tried to make a video for two some and did okay. What do you think about making videos that help you get better?
Yeah, yeah. So I think making videos is really good because, so like, let's say you can't do a problem. You can look up the solution, you can code it yourself, and then the next step is like, can I actually explain it to someone else? Um, and if you can explain it to someone else, then that's really good. And then also what you can do for all the problems that people really don't do is you can just write, like, just start writing down time and space complexity for every problem you do, and then like that will give you like 200 problems of practice, and then you'll be really good at that.
I see.
Yeah, like basically.
Okay. Thanks, Alpha. We'll
Yep.
do some more system design. Let's shoot another system design video maybe next week or actually the
Yeah,
week
next
after
week's
because I'm
good.
in Chicago.
Yeah, it's totally fine. Okay,
Okay.
cool. Catch you
Sounds
later.
good. Catch you. How long has the stream been now? How long has this stream been? Chat. Almost 9 hours? Okay, we got one more. We got one more interview in. Pablo, you're in the chat, right? Holy crap! That's it. Okay, okay, okay. No, you don't have to send me your LeetCode account. How many questions have you done, Pablo? Or we'll talk about it in your. You DM me. DM me.